So that's okay. But are you excited to enter into 10th? Why? You want to remain kids? डर लग रहा है कि तुम्हें डर लग रहा है क्यों? अरे पास तो कोई भी हो जाता है, पास के आगे की बात है। आजकल कोई फेल होता है क्या? नहीं, कोई नहीं होता है। चलो, जिस गली जाना नहीं है उसके बारे में सोचना है। बताओ, लास्ट लेक्चर में वेयर डिड वी स्टॉप? Part A we completed, right? Anybody has any doubt? I think last lecture you were not present. Okay. So those who were present or not present, if it is taught in school, if you have any doubt from part 1, ask me. Otherwise, we'll start with part B, and then we'll discuss questions in the second lecture, so that it will cover up for all the best part. Okay. So proceed with part B. Yes. Or do you have any doubt? Just take a look at what we covered in the last class. Doubts from part A. Magnetism. Uniform field, right? So what is? So uniform magnetic field, which is doubt number 1. डाउट ही बोलना पड़ेगा बेटा, क्योंकि पढ़ा दिया मैंने। अच्छा, ये हो गया। ओके ओके, तो क्या होता है यूनिफॉर्म मैग्नेटिक फील्ड? एवरीबॉडी इज, एनीवन हु मैग्नेटिक फील्ड तो पढ़ा था ना, सबसे पहले बताया था मैंने। मैग्नेटिक फील्ड, so who will tell what is uniform magnetic field? चलो, किसी को याद आ रहा है यूनिफॉर्म मैग्नेटिक फील्ड क्या होता है? इक्विडिस्टेंट एंड पैरेलल, ये होता है। ग्रेट, ठीक है। तो नॉन यूनिफॉर्म जो इक्विडिस्टेंट नहीं है और पैरेलल नहीं है, दोस फील्ड्स आर नॉन यूनिफॉर्म। तो तुम्हारे को डायग्राम दिया है। और क्या क्या किया था हमने? देखो, डाउट तो टॉपिक जो पूरा कर लिया है, खाली मुझे ये बताओ डाउट किसमें है? टॉपिक्स तो हमें पता है कि ये उसका पार्ट ए का टॉपिक, ठीक है। न्यूट्रल पॉइंट्स का कॉन्सेप्ट क्लियर है सबका? Everybody knows what is neutral point? चलो, let me ask you, suppose this is east, west, north, south, ठीक है। अच्छा, न्यूट्रल पॉइंट वो पॉइंट होता है where the magnetic field is 0, ठीक है। एट न्यूट्रल पॉइंट मैग्नेटिक फील्ड होता ही नहीं, इट कैंसल्स। तो जो तुम बोल रहे हो इक्वल इन मैग्नीट्यूड, मैग्नेट का दोनों का इक्वल और ऑपोजिट होता है, इसलिए वो क्या करता है, वो बोलते कैंसिल कर रहे, ठीक है। अब तुम मुझे बताओ, दो केसेस में वी हैव डिस्कस्ड न्यूट्रल पॉइंट, राइट? व्हेन द नॉर्थ पोल ऑफ द मैग्नेट इज अलोंग द नॉर्थ and when the north pole of the magnet is along the south, तो बताओ दोनों के इसमें न्यूट्रल पॉइंट्स कहाँ पे? अर्थ की फील्ड की डायरेक्शन क्या है? हमेशा ऊपर ही है, ठीक है। अर्थ इज एवरीवेयर अपवर्ड ओनली, हर जगह पे। तो अब तुम बताओ इसका फील्ड कहाँ पे कैंसिल होगा? साउथ से फील्ड कैसे बाहर आती है ना, नॉर्थ से भी ऐसे आती है। तो अब क्या होना चाहिए? यहाँ पे कहीं न्यूट्रल पॉइंट बनना चाहिए फिर इन दिस केस, है ना। और इन दिस केस क्या होगा? ऐसे बनेगा, ओके। साइड में बनेगा कि सामने सामने बनेगा? नॉर्थ और साउथ में कैसे? हाँ बताओ, तो इसका मतलब इस पे नहीं बनेगा। क्यों नहीं बनेगा? वाई? एसिड यहाँ पे बनेगा, इज इट करेक्ट? नहीं, क्यों? देखो, ये साउथ और ये ऐसे है, ये मैंने सही नहीं बनाया एक्चुअली यार, ये एक्चुअली ये इस डायरेक्शन में जा रहा है ना, नॉर्थ से बाहर निकल रहा है साउथ, ये तो डायरेक्शन ही गलत होगी, साउथ के अंदर जाता है, तो कैंसिल कैसे होगा? तो सेम डायरेक्शन में हो गया, तो इट विल नॉट कैंसिल हियर। ठीक है, ये भी सेम डायरेक्शन है, तो कैंसिल होगा? नहीं होगा। समझ में आ रही है बात? ना, कैंसिल तब होगा जब मैग्नेट का फील्ड और अर्थ का फील्ड ऑपोजिट डायरेक्शन में हो। ये कहाँ पे मिलेगा? देखो, ये ऐसे अगर आता है तो ये लाइन पे कहीं मिलना चाहिए। अपोजिट डायरेक्शन कहाँ पे हो रहा है? जब नॉर्थ से साउथ में आना ना इधर, तो ये जो इसमें जा रहा है वो क्या करेगा? सीधे साउथ में घुस जाएगा ना, ये सेम डायरेक्शन, ये वाला भी ऐसे ऐसे निकल जाएगा। ठीक है, लेकिन दिस वन, राइट, when it is close to magnet, this field will be stronger, so this field will exist near the magnet, but as you go along this line, which is the line bisecting the line joining north south, which is magnetic axis, वो यहाँ पे कहीं पे opposite direction में इसको cancel कर देगा। It will cancel this one, and it will also cancel this, जो ऐसे वाली field आ रही है। Okay, so the neutral point for this orientation of magnet, when the north of the magnet is along the north of the earth, exists on the perpendicular bisector of the magnet on either side from the center of the magnet, and it is equidistant on both sides. Understood? So this is the logic. Neutral point समझा? तो हर मैग्नेट को दो होता है। ठीक है, जब डायरेक्शन ऐसे होगा तो परपेंडिकुलर बाइसेक्टर पे होगा। अब देखो, अब अगर हमने मैग्नेट को ऐसे रख दिया, तो सबसे पहले अर्थ की लाइन तो हमको मालूम ऐसे ही आ रही है, अब नॉर्थ ऐसे आ रहा है और ये ऐसे आ रहा है, then it will repel, यानी ये इसको ऐसे रिपेल कर देगा, ऐसे साइड से, अर्थ की फील्ड को साइड से रिपेल करेगा। यहाँ पे क्या किया? अर्थ की फील्ड को एब्सॉर्ब किया, लेकिन on the both sides of magnet the field direction is opposite to earth's field direction. Here the earth field direction is repelled. अब मैग्नेट की फील्ड डायरेक्शन क्या है? ऐसे ऐसे। ठीक है, so नॉर्थ से बाहर आ रही है, so where is the direction of earth and magnetic field? Opposite. It is opposite in along this line, right? So what happens is, now close to the magnet, magnetic field is stronger, so away from the magnet, somewhere on the line, this earth field and this magnetic field will cancel each other. Likewise here, earth field is going up and this is coming down, equidistant from the center, cancel. That's it. Only these two things you have to remember. Okay, now I think this would have been the only doubt. Is there any other doubt? Rest is properties of magnetic field line, which we have discussed many times, right? Okay, let's begin with the electromagnet and its uses. What is the electromagnet? First of all, it is not a permanent magnet like your power magnet. Okay, so it is, first of all, it is a temporary magnet. Which is by winding the conducting wire by winding the conducting wire over the soft iron core in the form of a solenoid. Okay, what is solenoid? It is basically that is cylindrical wire. ठीक है, तो ये होता है. तो देखो, suppose you have a soft iron bar. What is it? Soft iron bar, right? Now we are trying to wind the wire on top of it. So first see how to wind the wire on it. We have a soft iron bar. Now we are taking a wire from behind the marker and now we are wrapping it like this. How can we wrap it? See here. This is the soft iron bar. I can take the wire from behind and wrap it like this. Other I can wrap it over it by keeping the wire in front. So there are two ways in which I can wind the wire on it. So let us say I am wrapping it from behind. So how will it look like? Like this. And this wire is having some kind of a coating, okay? So they are not this much spread, they are very close to each other. But there is no electrical contact between the turns because it is coated. So it will be shiny copper wire because it has a transparent coating. So there is no, so here it is a plastic coating or rubber coating, right? But over here it is painted. Okay. So there is no electrical contact. So this is how the wire will be bound. So at this end, if the wire was taken from behind, at the opposite end, it will come from front. You can see for yourself. If you take the wire from behind, wrap it, from here it will come from front only. So don't show in the diagram both the wire from behind, it will be wrong. The other winding would be something like this. So now you are winding it in the front. Then it will be like this. And this side it will be from behind. Is the difference clear? Here when you wind it like this now, clockwise. In this case it was wrapped anti-clockwise on the left side. So is it a magnet? Once you have the soft iron core and you have wound the wire on it, is it a magnet? Yet? No. You have to pass current. Now, when the electric current is passed to the wire, it develops, it acts as magnet. Okay, so it acts as a magnet only when current is passed through it. So how can you pass the current? This is how you can pass the current. This is rheostat to vary the amount of current. So current will flow in which direction? This is positive. So it will go away from the positive terminal. Always current will go away from the positive terminal, right? So then the current will come downward. This is how the circuit is complete. Okay, understood how to draw the diagram? Now I told you that it becomes a magnet. So therefore it has to have poles. Now which will be which pole? Which end is what pole? Left side will be which pole? So there is a rule. Give the attendance sheet. Now see, when the wire is wrapped anti-clockwise, right? So when you see from this side, you will see a anti-clockwise direction. Is it clockwise? When the wire is from behind, how will you see? You will see that it is in the clockwise direction, right? In this situation. And if you see from this side, the current direction is anti-clockwise, isn't it? You understand what is clockwise and anti-clockwise? In the same direction as cradle of the clock, it is called clockwise, and opposite is anti-clockwise. So there is a rule. When the current is anti-clockwise, the pole developed will be north pole. Current will develop north pole. And clockwise current will develop south pole. So this you have to remember. Right? How to remember? Now this is clockwise. So how do you write S? You write S like this, right? So you match this direction of S. Okay, both the directions you match. This is a south pole. Here now you make a N. Dot, and now you match the direction of N. Okay, so this is how you will remember it. So this is called clock rule. Using clock rule, you will determine which pole will be developed. So for both pole, and always if one end is clockwise, the other end will be anti-clockwise. Now, for this you identify. E. अभी लेक्चर ले रहा हूँ फ्री होऊंगा फिर बोल कर 8:30 बजे तक So what is it? You have to tell me what are the poles in this case. Which one, sir? Acts as a magnet, and magnet or electromagnet? Magnet. We call it electromagnet. Why electromagnet? Just complete it. Because unless the current is caused, it will not act as a magnet. And it is artificial, like you said, because it is man-made, right? So temporary, artificial magnet is made by winding. So I hope you have understood now how to make an electromagnet. Now tell me what will be the polarities in this case of the left side and the right side. Which is north, this will be north. This will be north, and this will be acha. How? ये साइड क्या है? नॉर्थ बनेगा. अच्छा, करंट डायरेक्शन सबसे पहले क्या करते हैं? करंट डायरेक्शन माना. अभी मैंने बैटरी भी उल्टा कर दिया. सेल करंट कैसे आ रहा है? ऐसे जाएगा. ऐसे आएगा ना. अब ये क्या बन गया? नॉर्थ कैसे? अभी साउथ ही बना ना, ये क्या है? अभी तुमने यहाँ से जब लूप देखोगे तो हाउ इज द करंट? अभी भी क्लॉकवाइज ही है, isn't it? This is clockwise, so no change. I made two changes. Minus is plus. What I did, I changed the winding of the wire, and I also changed the cell terminals. So it doesn't make any difference. It's like what I have done is I flipped this and I also flipped the wiring. So there are various combinations possible. So be careful. So first thing you will do is you will decide the current direction. So current direction say you will get to know the loop direction. Okay. Now here it is anti-clockwise only. This side also is anti-clockwise. So this will be north only. See, this is how they trap you. So I have to be careful. If I would have given it like this, if I would have only did this and this, right? Then what will happen? Then the current direction will be opposite. Now see, how it has become anti-clockwise. And here it will become, if this is up, and from behind it will be down. This is clockwise. Understood? So I think now you should get it. This is clockwise. This will be anti-clockwise north. Okay, so question may come on identifying the poles of the electromagnet. So when and what is this? What is this called? What is this? Wire किसके ऊपर लपेटा है? Solenoid is this. ये जो wire है, this is called solenoid. Solenoid or cylindrical coil. Coil मतलब the wire, which is like a spring, okay? So that is called solenoid, the wire. This can exist without this rod also. So it will have magnetic field. Because of this rod, this iron, which rod it is? Soft iron. I told you it has to be over a soft iron core. This is soft iron. So is the components of electromagnet understood? Can we make an electromagnet without a soft iron core? Yes. But its magnetic strength will be less. So when we insert the soft iron core, its magnetic strength increases by many times. You will understand the details in 12th standard about it. But right now you just know. Okay. So soft iron has two purposes. One, it is easy then to wind. Because if there is no support, how will you wind it? Okay. So it helps you wind it, plus it helps you increase the magnetic field strength. What are the other ways in which magnetic field strength can be increased? What is responsible for the magnetic field? The current. So we can increase or decrease the current. Okay, so right now low current, so if I shift it on the left side, resistance will be reduced, current increases. So there are three ways by which magnetic strength can be increased. Magnetic field strength can be increased by first increasing the magnitude of current, increasing current magnitude, Second, increasing the number of turns of wire. Okay, if there are 10 turns, let us say it has x speed. If you make the number of turns 20, it will become 2x. Got it? So increasing the number of turns. Of turns in the coil. Right? Third is inserting soft iron core. Inserting soft iron. I will read it for you, don't worry. Inserting soft iron. Okay, so I have told you the construction of electromagnet and how you can vary the magnetic field produced by it. So what are the three things? Tata, what is the first thing? How can we increase? Increasing the current magnitude or magnitude of current, whatever you want to write. Then second is by increasing the number of turns. अभी कितना है? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. अगर मैं 10 के बजाय 20 कर दूं, then its field will be double. Okay, how will we recognize that? Because it has all the properties of a magnet. So if I keep a magnetic compass, it will deflect. So initially, if it was deflecting by 10 degree, now it will deflect by 20 degree. Okay, that way. So is it understood? So it will show everything which a bar magnet showed, like all those field lines, exactly same like bar magnet. When you hang it, it will rest in north-south direction. Okay, all those properties it will show now. But only when current is going through it. The moment you switch off plug key ka plug nikal diya, then it will not act as a magnet. Clear? That's how it is temporary magnet. So there are two types of electromagnets. Types of electromagnet. I type and U type. Now this is I type. So it depends on the shape of the iron, soft iron core. This is like a sleeping eye. Okay, so this is I type electromagnet. If the iron core is bent in U shape, horseshoe magnet, then it is U type. Okay. So these are the only two. So I shaped and U shaped. Don't write type, write shaped. Now I shaped I have already explained to you. These are both I shaped. Okay. I'll now explain U shape. So here the soft iron core will be like this. So make a U and make it double like this. Now what you are supposed to do? Wrap the wire around it. So what will we do? So if I am wrapping the wire like this, okay. So it has come from below, right? How the wire has been there? From below. So here also it will go from below. But on this side, it will go from above. Below and above. Because These terms should be opposite. Okay, so we'll get it opposite only when we do like this. See, on this side it went below, right? And here it has come out above. Same like your I shape. Behind, above. Okay, so here also. And at this end, you have to be careful. This was below, here also it will be below only. Okay, below, and then it is above. So there are two ways to remember. Is it clear? Now you have to pass current. So how we can pass current? To connect cell. Now you identify the holes for me. And in the book, they have shown this U to be like slightly stretched inside. Like this. You can also do that. Now tell me what hole will be this end and what hole will be this end. First you draw the diagram. In this chapter, no matters, only hole identification types of magnets. Everybody understood? Draw it once. I want to see the diagram. This going from above or below? So this is below. It's also yeah. Already above, right? This hand it will go. Okay. Like here it is above, so above there. This one from below. Okay. This is where this is what about I is going to be there. So you don't have to write the south and south will be here. Close. This is south. Okay. So when you write these poles, okay. So this is your south and this is your north pole on the magnet. So keep it little bigger so that you can write the poles. This is the rule to identify the pole. Okay, so just you see in the book. In the book also they have actually taken, but draw this close to the magnet, not very far. Who has completed the diagram? Show me. Okay. But you know, like this should not enter from above, from the side it should. You entered it from above, but it is correct. Completed. Yes, this is going from above, right? Okay, so I think most of you have drawn it right. I have seen yours. Right. So how many of you got it in first attempt? Those who got it correct in the first attempt need to practice more. Because in the second attempt you'll make mistake. Okay? Right? Because you'll feel ki samajh aa gaya, so you'll become lazy. So you need to practice once again. Right? Okay. Now tell me the current direction. So this is positive. Okay? How will the current go? On the left side or right side? On the left side, away from the positive. Okay? Current is always away from the positive. So now it will enter. So this is the direction, right? So just and then from below, this will be the direction. So here, this is the direction everywhere. Same direction. First, only draw the direction in the first and last one. Same direction it will be. Okay? But then when it is going from below, now the direction changes. So you see, in both the cases, you are getting different directions. Is it different? So when you see from here, you get clockwise. When you see in this direction, this loop will be clockwise. So which pole? South. This will be south. And you see from above, this will be anti-clockwise. So which pole it will be? North. Clear? This is how you will identify these poles. That's it. So, and everything which is applicable for that is also applicable for this. Right? Okay. How to change the current? If I want to see the current, then I need to put a ammeter also. It's not required. Only if you want to see, if you vary the current, how much current is flowing through the circuit, you can see from here. Polarity will be whichever is the polarity connected to the meter, that will be polarity, and this will be opposite. Clear? So this is how you can see. You can increase or decrease the strength of the magnet. In the book, they have shown battery. We have shown just cell. It's okay. Right? If you want to increase the current, how to increase the current? One is by changing the rheostat jockey position. Other is by doubling the cell. Okay? This is how you can play with the current magnet. Is everybody understanding or am I teaching myself? Huh? All good? Okay. All right. Sure. So you can see in the book ways of increasing the magnetic field of electromagnet. So what are the ways they have given? So the soft iron core they have not given. You will learn it in 10th standard, but it's okay. I just gave you that as well. Anna? So in your answers, Don't write this. This is additional. You will learn about it in 10th standard. नहीं लिखा तो भी चलेगा. But number of turns and magnitude of current. These two things you write. So electromagnet समझ आ गया?
Yes.
Now what is permanent magnet? You already learned about it. Right? Just read, and so now you read all these things. Permanent magnet, I have already taught you. Part A was all permanent magnet. So read till 10.12 and ask me if you have any doubts. Then in the next class, I'll begin with uses of electromagnet and one application, electric bell. Electromagnet is a temporary magnet. Power magnet is the permanent. Wait. So you know what is permanent magnet, right? How to make a permanent? How do we make magnets? In nature, we have what kind of magnet? Natural magnet, which is available in irregular shapes and all. But the permanent bar magnet that we get, how do you make it? Yes, steel use करते हैं, soft iron core नहीं use करते. क्या use करते हैं? Steel. और कहाँ पे रखते हैं उसको? वो जो I shape वाला था ना, that core is now steel, and we keep passing the current for a very long duration. Then anyway it acts as a magnet. If it was a soft iron core, its magnetism will stop right when we switch off the current. But for steel, it becomes permanent magnet because it retains the magnetic behavior even after the current is switched off. So this is one way we can manufacture permanent magnet. वो जो solenoid था, उसके अंदर जो core रखोगे, अगर soft iron core है तो temporary रहेगा. But if you keep steel, then it will convert into permanent. Is it understood? Okay. Same holds true for U-shaped magnet. If this core is soft iron, temporary. Steel, permanent बन जाएगा. There are other ways to make permanent magnet. Dig a pit in earth in the north-south direction, then keep a steel bar in that for a long duration. After some time, it will develop magnetic behavior. Okay? So it depends on what substance we choose to make a magnet. That will decide whether it will be temporary or permanent. So is there any point you want me to clarify out of 6 points? So you asked me after the break. I think now is the break time. Oh no, when is the break? 7:30. मैं 5:15 सोच के चल रहा हूँ. Okay. So let's go point by point. It is made of soft iron and permanent magnet is made of steel. Second, it produces magnetic field so long as current flows in its coil. Right? So that is, it produces temporary current one. Second point, for permanent, it produces a permanent magnetic field. Current band kiya to bhi it remains like a magnet. Third point, the magnetic field strength can be changed. Can we change the magnetic field strength in permanent magnet? No, because now current is not flowing. Still it is magnet. Okay. So this is the flexibility with electromagnet. So it is also an advantage. We can change the strength of the magnetic field of the electromagnet at will or as required. Okay. Fourth point. Magnetic field of an electromagnet can be very strong. Obviously, if we pass a current of large magnitude or if we increase the number of turns, right? So magnetic field produced can be very large. Like in permanent way, whatever is available, whether large or small. Okay. Then fifth is the polarity also can be changed by changing the current direction. Can we change the polarity for permanent magnet? So physically घुमा के रखना पड़ेगा. But in the same position, can the polarity be changed? No. Here we can just change the direction of current. Polarity will be changed. Right. Next, it can easily be demagnetized by switching off the current. It cannot be demagnetized. ये समझ आ गया? Like if it is a temporary magnet, switch off the current, it loses all its magnetic behavior. But if it is a permanent magnet, it remains a magnet only, right? So how it hampers your performance? It's like this. So if you have to pick up iron scrap, which magnet will you use? Temporary or permanent? Temporary. Because when you have to pick up, pass the current, all the iron scrap will get stuck, and wherever you have to keep, right? Let them switch off, and it will drop it. Okay, so it will be useful. Like the same object acts as magnet in some situation and not non-magnet in some other. Then you can work out. Like, but if it is permanent, it will always hold it forever. Okay? Clear? Now, read the advantages of electromagnet over the permanent magnet. These were the advantage. Last 3 points. Earlier. So 3 advantages would be of electromagnet. Over permanent magnet. The last 3 points in the table basically. So what is it? Magnetic strength can be changed. Can be varied, changed. What else? The polarities can be changed. Okay, these are the 2 advantages. Is there any more? Yes. Okay, so that comes under this. Okay, so first 2 is similar. Okay, so understood. Next are uses. Let's discuss the uses. So we'll take turns in reading. Okay, so each one of you will read it. So we'll start with the last person.
So electromagnets. Electromagnets are used for the but this thing is not for very
Iron scrap.
girders, etc. Particularly when it is not connected to the electromagnets are used to get 20,000 kilograms.
Like 20 tons. Can you imagine how strong it can be? 20 tons. The container that you see, no, the large container trucks, 20 by 20, they carry load of 17, 18 tons. So almost one full container can be lifted. Okay, so that's pretty, and we can increase the current to make it more powerful as well. Right?
So I know that is stop so that I have this.
Yes, understood? Yeah. Why are you laughing?
So he's sitting back and laughing.
He is looking back and laughing, and therefore you are also laughing. You should stand up and scold him. Why are you laughing? And why are you looking back and laughing? Okay, chalo, second point you, and then he will read. Third point.
Loading for dances, the pipe.
Furnaces, furnaces. What is a furnace? Bhatti. Okay? Like at home we have stoves, but in industry we have large mechanism to heat or melt metals. Okay? बहुत बड़ा चूल्हा ऐसा बोल सकते हैं उसको. ठीक है? जिसके अंदर क्या हो सकता है? भस्म हो जाएंगे आप लोग. ठीक है? So these are industrial furnaces which are very big heating mechanisms in which you can put, various iron like raw iron, melt it and then separate. That's what you call smelting. Is it called smelting? Yeah. Yes. So for that you need large furnaces. No, wait. Read.
For separating iron pieces from debris and ores where iron exists as impurities.
Bracket में पढ़ो.
Example for separating iron from the crushed copper ore with copper mines.
So see, different substances have different melting points. So some of it which is melted, it can be separated. You tilt and with the earth's gravity it will flow and come out. The one which is not melted will still stay back. Or you have some filtering mechanism. Okay. So the point is, we need. Why do we need magnet? Basically, these are such large furnaces. Any human which can go, no human can go near it to load it. You have to load the furnace before melting, right? So humans don't need all sector. So therefore, you pick up and load it. Okay, that's why, right? So second is for separating iron pieces from debris and ores. Like copper is non-magnetic substance. Copper is non-magnetic, and if you have a mixture of copper and magnetic substance, then you scan with a magnet. So all the magnetic substances will get stuck to the magnet. So that is the third application. Understood? How it works as separator? How it acts as separator? How?
So when the current is switched on, then
the mixture of magnetic and non-magnetic substance में से, if you keep the electromagnet above it, magnetic वाला चिपक जाएगा, non-magnetic नीचे रहेगा. ठीक है? That is third point. Okay. Fourth.
for removing pieces of iron from
Oh, yes. So suppose if a factory worker is working at some filing device and some iron scrap got stuck in the body, right? Now, one way you can just like make a cut and remove it. But if you don't want to make a cut, keep a powerful magnet, it will, bring it back because it is magnetic, right? गया एक रास्ते से था, मैग्नेट इधर लगा दिया तो पूरा घूम के आएगा. Which is better, surgery or Surgery better है ना? We can see and cut and remove it, right? But अगर if it is not a vital organ like eye and all, इधर उधर है तो खींच दो, इधर से भी आ गया तो क्या फर्क? It will be healed. हाँ? निकलेगा, हाँ, काट कूट के निकल रहा. Anyway, means कभी ऐसा हुआ तो anesthesia दे के करेंगे, हाँ, don't worry. So local anesthesia you'll be able to see, but you won't feel the pain, हाँ? जैसे डेंटिस्ट बाबा लोग करते हैं ना, डेंटिस्ट बाबा, कोई गया है डेंटिस्ट के पास? How many of you have seen dentist? अच्छा लगता है ना?
देखा है लेकिन
वो डर इसलिए लगता है कि the place is not numb. First time जो चेक करने के लिए ड्रिलिंग करता है ना, तो place is not numb. That's when you have the first encounter with reality. चलो ठीक है, दांत साफ रखा करो, ठीक है. Fifth one, you.
In scientific research, to study the magnetic properties of a substance in a magnetic.
So what happens is now. So how to study the magnetic behavior of a substance, right? So substance which can get attracted easily, they are magnetic substance, and those who are attracted not so fast, then they are less magnetic, not non-magnetic, lesser. So that way. So here there is a magnetic field between north and south pole. What kind of magnetic field is there? It will emerge from here and it will enter the south pole. Okay, this kind of magnetic field is here. So U-shaped magnet is a source of magnetic field, and you can now keep the magnetic substances here and study their properties by keeping it right in the line. क्यों हंस रहे हैं? क्यों हंस रहे हैं?
सर ये ऑन कर रहे हैं.
हम सबको हंसाना, अकेले ही होता है. हाँ? क्या जोक है? ऐसे ही है सर. ठीक है. So have you understood point number 5? Okay. 6th.
Telegraph, electric tram, electric motors, microphone, loudspeaker, etc.
Telegraph तो अभी हम यूज नहीं करते. Do we use telegraph? No more. है ना? You probably might not even have heard about it. Have you heard about it? Telegram आया है पुरानी पिक्चरों में, you might have. So earlier we did not have telephone exchanges, not in this number. Like today, तो you have an exchange in your pocket. पहले क्या होता था? बुकिंग करनी पड़ती थी, टाइम लेना पड़ता था, वो टाइम पे ही तुम कॉल कर सकते हो, क्योंकि एक्सचेंज में कनेक्ट करेगा तुम्हारी लाइन को. So it was very tough days earlier. But now you can just see the person and have a video call, and that too for free. Can you imagine talking to a person sitting at the other side of the world just to speak with him, have an audio conversation? It used to take days of pre-booking. भाई आज मैं आ रहा हूँ और वो पार्टी भी उसी टाइम पे आएगी, and then the exchange people will connect on the both sides. Right? Now it is so easy. So it is very hard to imagine how people live nowadays. Okay. So just to tell you, all these devices actually make use of electromagnets. Okay? Like when you're using mic, what are you doing in mic? Speaking. So sound energy is converted into electrical energy. Okay? And the opposite happens in speaker. That electrical energy is converted back into sound. So there has to be some vibrating object. That is called diaphragm. So have you seen your speaker? There's something which keeps shaking. That is called diaphragm. Similar diaphragm is in mic also, but that is smaller. Okay. So the diaphragm is the vibrating object. So when the electric signal current, the variation in the current, where is the vibration of the diaphragm? That's when the sound energy is decibeled by us. When we speak, that diaphragm again vibrates, but now it is converting sound energy into electrical. Okay, so that's microphone. But for us, we have to study about electromagnet in the electric balance. That I think I'll take in the next lecture. Okay, after the break.
Yes.
Next class is the next lecture. Where is your stocks wearing specs? Okay. All right.
Yeah, do it. Now. See, it will have to be blasted. Sorry, this one. Sorry, do you like why you ask? Because we will have to try. We'll go to some of that. बाथरूम वापस जा रहा है नीचे नहीं गया है हमें फर्क नहीं पड़ता देख हमें जीरो पसंद है अभी जस्ट लेके आओ
That coincidence.
कैसे काटे किलो सोडा आज जल्दी बहुत थर्सडे को क्या है संडे थर्सडे को हमारा पीटी है लोग पीटी है तो जरूर जब एलेक्स ने बोला था एग्जाम में एक बार भी नहीं नहीं था मैं फर्स्ट
Okay. Let's begin with construction of electric bell. So now we are going to learn use of electromagnet. A use over. This is electromagnet. How to use electromagnet for making electric bell. Yeah. It's very simple. सबसे पहले we'll draw the gong. So everybody understand what is the gong? जो साइकिल की बेल आती थी ना मैकेनिकल पहले देखा है क्या? So when you press with the thumb, it hits it on the gong. जो वो मेटल होता है ना जिसपे वो हैमरिंग होगी तो आवाज आएगी ट्रिंग 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 उससे. So this is your gong. Okay. So this is hammer. What is it? Hammer. हथौड़ा जैसा हैमर नहीं है मतलब उसको बोलते हैं अपन हैमर है क्योंकि ये जाके हिट करता है गॉन्ग पे. ओके अच्छा, अब ये कैसे हिट करेगा? हाउ विल इट हिट द गॉन्ग? There's no different color. So this hammer, pay attention. तू जरा इधर बैठ ना, तू तो अटेंशन वाली पोजीशन में ही नहीं, थोड़ा इधर आ. So this hammer is connected with a metal strip. एक elastic metal strip is there. So hammer has two things. This is a big metal strip. Elastic का मतलब क्या हुआ? If you try to change it, it will again come back to its original shape. क्या चालू है?
एक बार आगे चले गए.
अच्छा, तो ज्यादा ताकत मत लगा ना.
चलिए पीछे ले.
ठीक. तो ये समझ आ गया? अभी तक हमने क्या देखा? We have a hammer which is connected with a metal strip. और metal strip कैसा है? Elastic. ठीक है? अब क्या हो रहा है इसके अंदर? I will just. So this is a metal strip. Yeah. Now we have to make a electromagnet. Electromagnet कैसे बनाएंगे? See here. This is a U-shaped magnet. चालू है आज, बहुत ज्यादा हवा आ रहा है, क्या बात है? भूख लगी है क्या सबको? ब्रेक के बाद थोड़ा सिचुएशन चेंज होगी. ठीक है, सो दीज थ्री थिंग्स. ठीक है, अभी पहले ये तीनों चीज बना के नाउ वी विल पुट इट इनसाइड अ प्लास्टिक केस. ठीक है, ऐसे केसिंग होता है ना बेल का, ऐसा ये हो गया. ठीक है, नाउ वी हैव टू मेक द वायरिंग. ओके, इलेक्ट्रिकल कनेक्शन कैसे करेंगे? देखो अभी ये सिंपल है, एक यहाँ कनेक्ट करेंगे जरा. दिस इज स्क्रू, राइट?
सर वो उधर लगे वो बम है.
ये कौन है?
नहीं इधर भाई.
क्या बोल रहा है?
वो ब्रेक में बजा है.
हाँ, वो दिखता है क्या? है क्या? जो बोल रहे हैं? आया आया. ठीक है, तो अब देखो, अब ये सब चीज इसके अंदर है. तो जो प्लास्टिक का बॉक्स देखा, राइट? तो मैग्नेट इज इनसाइड इट. अब इसको कनेक्शन कैसा करने का? देखो इधर हमने कनेक्शन ऐसा कर दिया. इसको डायरेक्ट भी कनेक्ट कर सकते हैं, रियोस्टेट की जरूरत नहीं है. इसको डायरेक्ट करेक्ट कर सकते हैं क्योंकि इसमें हम करंट तो वेरी करेंगे नहीं। ठीक है, नाउ व्हाट वी विल यूज इट, विल यूज अ स्पेशल स्विच। This is a press switch. When you press it, only then it will make contact. Okay, remember this. When you press it, it will make contact. Bell switch is different than this kind of switch. This has a permanent position, either on or off. But bell is always off. When you press it, only that moment it is on. But the moment you leave it, it will be off again. Okay. Now, will the bell function? No. So first what we are doing is there is a screw here. Okay. So first this connection will be to the screw here. The diagram may look little different than in the book, but this is how it is. Okay. Then this is a metal strip. This is also conductor, right? Then what is happening is there is maybe there is a screw here, let's say, and there is a screw here. Okay. This wire, first the current goes here, then we have a connection wire over here also, right? Via this metal strip. Now we will wind it on top of this is gone from above, so here also it will go from above. Now it will go from below. Okay. This is what it is. Now is the circuit complete? Okay. Now how is the current direction when the switch is pressed? This is key. The current direction will always be in this direction. Like this. Is the circuit complete? This is the construction of your electrical. So I will now name the points. This is A, this is B, then this is C, this is D, this is E. This is your cell. Oh, sorry, battery. Switch. Okay. Construction of electric bell. So where is the electromagnet? U-shaped. So is the steps for drawing the bell circuit clear in your head? First, draw the bound, then make a hammer, connect that hammer to the metal strip, Then next to it, make the U-shaped electromagnet. And then just do the winding. These are the steps, 4 steps. Right? In this order. 1, 2, 3. And 4th step is 5. Now we'll understand the working. What is the first step? Switch is shall I explain or are you still drawing the diagram? Okay. Switch on. So switch is pressed in on position and held there. So as long as it is held, it will keep ringing. How it will ring, I'll explain. Okay. You're done. Example is
Drawing, yeah.
नहीं आता है चलो ठीक है ड्रॉ करोगे तो मैं समझ में अच्छे से आएगा
Drawing, yeah.
चलो एक्सप्लेन की वर्किंग में ये ड्रॉ करने का तो नहीं आएगा ठीक है लेकिन वर्किंग समझो बहुत सिंपल है okay everyone pay attention first you will press the switch and hold it so when you press the switch then current will begin to flow before pressing the switch is it acting as a magnet no now see what happens when the switch is pressed this current flows through the metal strip okay and the moment it becomes magnet it will pull the metal strip towards itself okay so now this metal strip will move forward in this direction so this metal strip comes here let us say when it pulls it this end is fixed only this end is allowed to move forward so when this comes forward the hammer connected to it also comes forward and hits here. Got it? Now when the hammer hits to the gong, that time what is happening? It loses the contact. So now the current stops flowing because it is like it has lost the contact. Contact is broken. Then it stops acting as a magnet. When it stops acting as a magnet, this is an elastic strip I said. So it goes back. Here you are holding the switch. So current is reaching till here, but not going forward. But the moment this comes back, the circuit is completed again. Again, this acts as a magnet, and this continues till this switch is pressed. Okay, so there is a break of contact, again making of contact, break, make, break, make. So till this switch is pressed, this will continue. Turn, 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 turn. That's what will happen, right?
normal breakup and then they will say.
अगर तूने ऐसा कुछ किया ना, ऐसे डंडा लेके बाहर आई, ऐसा कुछ करना होगा, ज्यादा देर तक मत करना, थोड़ी देर ठीक है, कोई नहीं, ऐसा नहीं होगा, you're a good boy. तो then what happens, है ना? Understood? कैसे लिखेंगे इसको? Switch is pressed on. Then what happens? The electromagnet becomes active and pulls the metallic strip away from point B. Okay? It pulls the metallic strip away from point B so that the hammer attached to the strip hits the gong. Hits the gong, making a sound done. Right? This is the first one. So at this moment, since the metallic strip double L over here. Strip loses contact with point B. There is no current in the circuit, or the circuit is open. This जब भी ब्रेक होता है तो उसको हम क्या बोलते हैं? सर्किट इज ओपन. Therefore, electromagnet loses its magnetic field. Thus, the metallic strip goes back to point B and making makes the electromagnet active again. Okay. So step 2 and 3 is repeated till the switch is pressed. As long as the switch is held on. That's it. So I think it was quite easy to understand, right? So just divide the diagram into 3 parts and that's it. I have changed these screw name etc. as per my convenience, A, B, C, D. So it is much easier to understand. Yes, sir. These are not continuous statement, so make sense out of it. And these are like comma करके. So if you read it continuously, you'll not get the sense of it. That's very important. The metallic strip loses contact with point B. The circuit is open, therefore the electromagnet loses its magnetic behavior. Thus, the metallic strip goes back to this. What is its rest position? At B. Because it is elastic, so it will always try to be at its main position. This is the main position. So unless it is disturbed from there, it will always rest in its main position. Yes. Is the mechanism understood? How the bell functions? Now question. At our homes, do we have battery or AC? What do we have at our home? This, right? What is it? Cell? It is AC, right? So the question is, if I replace it with AC, will it work?
Yes.
How? Huh? हाँ, switch तो दबाना ही है. Question is, अगर ये AC में convert कर दिया, तो भी bell चलेगा क्या? कैसे? अभी इसका करंट का डायरेक्शन चेंज हो रहा है. बैटरी के केस में ये इसी डायरेक्शन पे जा रहा था ना, ठीक है? लेकिन इसमें क्या हो रहा है? एक बार पॉजिटिव, एक बार नेगेटिव, ऐसे ऐसे जा रहा है. और वो 1 मिनट में कितनी बार हो रहा है? 50 टाइम्स. 50 टाइम्स 50 साइकिल्स है. डायरेक्शन कितना चेंज हो रहा है? 100 टाइम्स. अब क्या होगा? बेल बजता है कि नहीं घर का? कैसे बजता है? Okay. तो कोई फर्क नहीं पड़ेगा, well will still work. You know why? देखो, समझो इसका ये क्या है? एंटी क्लॉक. तो ये नॉर्थ पोल था, ये साउथ पोल है. पोल से कोई फर्क नहीं पड़ता, because this is a magnetic substance. तो अगर करंट का डायरेक्शन चेंज हो गया, तो ये खाली साउथ नॉर्थ होता रहेगा. लेकिन since it is magnet, it will still pull it. तो कोई फर्क नहीं पड़ेगा. So whether you use a DC supply or a AC supply, in both cases your bell will ring. Change of polarity has no bearing on this. Because this is a magnetic substance. As long as it has a polarity, either north or south, doesn't matter. It will attract. Because this is not a magnet. It is just a magnetic substance. It will always get attracted, irrespective of the polarity. Understood? So that was the last para in your book. That sometimes may be asked as question. Note, the note part. Read the notes. Last para in the text. Note. Read the note. Forward अरे जी खड़े हो गए बैठो बैठो.
If an AC source is used in place of battery, the core of electromagnet will get magnetized, but the polarity at its end will change. Since attraction of armature does not depend on the polarity of electromagnet, so the bell will still be considered the switch case.
So they are calling the elastic magnetic strip as armature. Yes, right now. That armature metallic strip. I have just written metallic strip. Its name is armature. Okay. Okay. So this is also clear. Whichever power supply you use, AC or DC, it doesn't matter. Your bell will still ring as long as the switch is pressed and held there. क्योंकि जैसे छोड़ोगे फिर उसका कॉन्टैक्ट लूज. So with this, dear children, we come to an end of this academic year. I hope you enjoyed learning with me. I of course enjoyed teaching you all. So we still have some time. Make use of it. If you have any concept still where you need my help, just go through it. Okay? Or else we can take up some questions.
No, any chapter.
Any chapter, any chapter. Ask any chapter. So see you in 10th again. Before that, write your exams well. Right? Come on. लेक्चर देखिए बड़ा है. तो बीच में आए नहीं बहुत लेक्चर के लिए ऐसा क्यों? अच्छा तो अलग से अच्छा तो देखो अभी क्या है ना, सो ऐसा नहीं है कि देयर इज नो लेक्चर तो हमारा तुम्हारे साथ कोई कांटेक्ट नहीं हुआ, ऐसा नहीं है. सो आई विल बी लाइक फॉर दिस मंथ आई विल बी आल्सो कमिंग फॉर SAPS.
In SAPS
no, in SAPS you come. Those of तो मैं रहूँगा यहाँ पे. Or SAPS also. So it's not that I will stop visiting the center. I'll be around. Come with all your doubts, queries, and answer.
about rheostat, ammeter, and resistance.
Okay. So I'll keep this. I'll remove this. Okay. Okay, that's why you made a grin when I drew the rheostat. So let's say this is a simple circuit, okay, simple electric circuit. So what is the electric circuit? It is a closed conducting path. Pay attention. I'm just explaining some components of electric circuit. So what are the components of electric circuit? It should have a source of current, which is cell. Okay, so source. So this is a DC source. In this case, it is a cell. Then you need some mechanism to start or stop the current. For that you need key. Right? Once the current is running in the circuit, you need some mechanism to increase or decrease the current. Current, who opposes current? Resistance. Huh? So rheostat is a variable resistance. Right? So it depends. So the resistance is between these 2 points. This and this. This is full resistance. So this point, if you connect, so you have a choice. Rheostat has 3 terminals. In the circuit, you can connect only 2 terminals. So when you want to use it as a fixed resistor, then you don't use this, you just connect the circuit like this. Then it is acting as a fixed resistor. So the fixed resistor symbol is this. This is fixed resistor. Whatever it is, let's say it is 100 ohm, full 100 ohm will be always available here in the circuit. Right? Now this, let us say it is like 100 ohm resistor, full capacity. You can use it as a 10 ohm, 20 ohm, 50, depending upon where is this point. And the circuit is now connected here, not here. Okay. Now let's say 10 is here, 20 is here, so on and so forth, and this point is 100. So depending upon where, it's like hand regulator, right? Different 1, 2, 3, 4. So it runs at a low speed when the resistance is high. So at 1, it has maximum resistance, lowest speed. 2, 3, as you go on higher speed, that means you are reducing the resistance, you're coming here. Got it?
Yes.
So this is called rheostat. It is basically a variable resistance. Okay. So now, so you have a source of current, mechanism to start or stop, mechanism to control the current or regulate. This basically controls the current. Increase or decrease. If you reduce the resistance, current will increase. If you increase the resistance, current will reduce. And then you need some load, some appliance like electric fan or bulb, right? So I'll show the bulb like this. Okay, that's it. And now, since the current is increasing or decreasing, I want to know how much current is going in the circuit. Then I will use ammeter. Ammeter is to basically show how much current is going through the circuit. So you can see that the needle will fluctuate if you change this position. So this is ammeter. Used to measure current going through the circuit. And this whole thing is circuit because it is a closed conducting path, isn't it? Closed. It is a closed path. When it is open, when the key is removed. Okay, understood? Likewise, if you want to measure the voltage, potential difference, then you connect it across like this. So this will not tell you how much. So this is, let us say, 1.5 volts is connected here. Full 1.5 will not appear because it is distributed in various parts. So how much is across this? You can measure using a voltmeter. So voltmeter is always connected in parallel. This is called parallel connect because this and this devices are in parallel. Whereas this is series. One after the other is called series connection. So ammeter is connected in series. And this is connected in parallel. Okay. This completes, and this is your load. Load is like fan, any appliance, anything. I mean, when I say fan, this will be a toy fan, not this. Right? Cell 1.5 में नहीं चलेगा. उसके लिए कितना चाहिए? 220 वोल्ट में. ठीक है? Any other question?
Sir, what is resistance?
Resistance box is now here. You can have 1 ohm also, right?
Yes.
It depends on what position. So you have a very tight control over here, right? But resistance box has slotted resistance. Like resistance box will have 10 ohm, 20 ohm, 30 ohm, 50 ohm, right? 100 ohm, 200 ohm, 500 ohm, and say 1000. Okay. So basically, what is like a plug key, you have this kind of arrangement, right? Everywhere. So the key is plugged everywhere. I'll show you with the image. Which one? Add. Yeah.
Yes, मैं गिरी ना sir.
Continue. नहीं तो ये कर लेते हैं. नारायणी वाला कौन सा था? वो चलता है क्या नारायणी?
Sir, वो इंग्लिश के नाम है. पासवर्ड पता
So
है.
gets
Yes, मैं गिरी ना sir.
first.
Can't.
Each gets a box.
Yes. ऊपर ऐड कीजिए सर.
यहाँ पे
हाँ. सर वो हटाइए ना सर. बाहर हटाइए.
अब क्या करना है?
हटाइए ना सर. दोबारा. हाँ. Yes sir.
Resistance box.
हाँ.
Enter. तो ये तुम्हारा images हो गया. Now let's say I open this.
सर टीवी हुआ है.
दिख रहा है सबको?
हाँ. Cinematography.
Now see, this is a resistance box. ठीक है? देखो, अभी यहाँ पे क्या है? Can you see this? These keys are ये यहाँ पे गैप है देखो इसके बीच में, ठीक है? इसकी वजह से क्या कर रहा हूँ? इसको पढ़ा रहा हूँ.
सर कंट्रोल.
कंट्रोल दो आगे कंट्रोल.
कंट्रोल स्टोर.
Also no. चलो ठीक है. ये दिख रहा है?
हाँ.
Now see these key ये जो दो कनेक्शन है ना इसके बीच में गैप है. जब तक तुम की नहीं डालोगे वो यहाँ पे आएगा नहीं. ठीक है? So when you take the key out, वो वाला रेजिस्टेंस उसमें ऐड हो जाएगा. If you keep the keys inside, then there is no resistance, zero resistance. And these are the 2 points where it is connected in the circuit. तो रेजिस्टेंस वाला अगर यहाँ पे तुमने रियोस्टेट की बजाय अगर तुमने क्या कनेक्ट किया होगा रेजिस्टेंस बॉक्स, तो उसको ऐसे कनेक्ट करोगे. Let us say you are connecting these two resistance boxes. ठीक है? तो यहाँ पे तुम्हारा क्या है? ऐसे ऐसे रेजिस्टेंस बना हुआ है. इनसाइड ऊपर तो दिख रहा नहीं है तुमको. इसके बीच में ऐसा तुमको कांटेक्ट दिया हुआ है. ठीक है? These are all contacts. तो ये 3 का एग्जांपल लेके मैं बता रहा हूँ. ठीक है? Let's say these are the only 3 resistances possible. अब ये तुम्हारा है 10 ohm, ये तुम्हारा है 50 ओम, ये तुम्हारा है 100 ओम। अगर तुमने ये सब कीज शुरू में अंदर डाल के रखी हुई है तो भी एक भी कुछ भी रेजिस्टेंस नहीं, बिकॉज देयर इज अ कंटिन्यूअस कनेक्शन। कब रेजिस्टेंस आएगा सर्किट में? जब तुमने ये की निकाल दी। अब ये करंट कैसे जा रहा है? थ्रू दिस रेजिस्टेंस। गॉट इट? ये रेजिस्टेंस का है नीचे बॉक्स। गॉट इट? So this is called resistance box. The problem is you can either have 10 or you can have 10 plus 50. वो 60 हो जाता है. What about if you want 30 ohm? Can you have it? Rheostat में possible है. Because it can go from 0 to whatever is maximum capacity. So this is slotted. So it has steps of resistance available. There you can have any value. Is it clear? So you have more control in rheostat. But then what is the value of resistance in rheostat? That you don't know. That you have to mathematically find out using the formula R is equal to V upon I. Here you know what resistance you are selecting. So in laboratory you use both. Okay? Any other question? So rheostat I have answered. About ammeter and voltmeter, you see. So every device that you use, it has two terminals. You see the screw, no?
Yeah.
Wire, the connecting wires, you just lose it, set the wire tight. That is how you do the connection. Okay. Now let me show you ammeter. Ammeter is okay. So what do you have here? You come here. Yes, come. Now see, this is the ammeter, okay? Can you see? So this has got two knobs, okay? Black and red. Red is positive. तो ammeter में A दिखाएगा, voltmeter में V लिखा है. So initially the needle is at 0. Okay? So whatever is the current, it will show. So it is showing here. How many? What are the slots? I can't read it. So 20, 40, 60. So this is milliampere. So in your school, I think they will give you milli or microampere. They will not give you ampere. Ampere is very high current. Okay. Cell cannot produce current of ampere level. You will need amps. Is it clear?
Yes.
This is a digital type. This is analog type. Wherever you have needle, it is analog meter. Wherever the numbers come directly, you have digital. Okay. Now ammeter and voltmeter both start from 0. See, it is 0 in the middle, like this. It can go both ways, right? So for AC, you may use this because it can go in both directions, right? So when the current direction changes, the needle direction will also change. So in galvanometer, generally it is in the middle. Galvanometer is in the middle. It only gives you the current direction. Clear? If you want to see voltmeter, you will only see that instead of A, it is B.
So it's the same.
Yeah. No, not same thing. Look wise same, but use is different. L किधर है? E किधर है? You see, just instead of A, it is B. Here also you have two. So every electrical device will have two connections. Okay. Any other questions?
Sir, in electromagnetic, why do we stop adding?
Because we need temporary magnetism. नहीं तो कैसे पिक करके उसको ड्रॉप कैसे करें? सॉफ्ट आयरन रिटेन नहीं करता है, वो तब तक ही मैग्नेट रहता है जब तक उसमें से करंट जा रहा है, इसलिए उसका वो प्रॉपर्टी है ना? प्रॉपर्टी कैसा रहता है, जैसे एक बच्चा गाना गा सकता है, एक नहीं गा सकता, देखने में दोनों एक जैसे दिख रहे हैं, ठीक है ना? तो वो सबका सब सब्सटेंस, जैसे ये तो गाता है, ये तो हमने थोड़ा गाना सुनवा था सबको, ठीक है? आज गाता है ना, झूठ बोल रहा है ना, गाने से बचने के लिए, ठीक है? गा देना, इसलिए मेरे को पता है ना अभी थोड़ी देर पहले कि ये सब बहुत अच्छा गाता है, तूने बताया था ना मेरे को गाता है करके। कॉन्फिडेंट है। चलो, और किसी का कोई सवाल? अपने पास 10 मिनट है, ठीक है? हाँ हाँ, मैं तो गाता हूँ, ऐसा थोड़ी। मैं अपने 2 घंटे से गाना ही तो गा रहा हूँ, यही है मेरा गाना। ढूंढो, डाउट ढूंढो, सारे चैप्टर पलटी अल्टी पलटी करो। 10 मिनट है तुम्हारे पास, बहुत है। कुछ क्वेश्चंस करेंगे जी में? लेट्स टेक द क्वेश्चन। वॉल्यूम है सबके पास? टेक्स्टबुक है सबके पास? है क्वेश्चन, electromagnets are made up of soft iron and permanent steel. छोड़ो ना, बता दिए अभी यार। Name one device that uses an electromagnet. कितना क्लियर हो गया? Name the material used for making armature of an electric bell. Give reason for your answer. Name the material used for making the armature of electric bell. Yes, metal. Metal strip, not steel. Metal strip. Okay. What's the reason? Because it is. Is can return to the original position after. Metal strip is what? It gets attracted towards. It's a magnetic substance. क्या लिखना है? It is a magnetic substance. ठीक है ना? So that's the reason, right? Question number 13. How is the working of an electric bell affected if alternating current is used instead of direct current? No effect. Okay, it will still function. Okay, so these questions are asked. State 2 ways through which the strength of an electromagnet can be increased. Batao. Raise your hands. Question number 13 है ना? Which? By inserting software. वही बता दिया. What are the other two? Other two, sir, tied. One you will tell, one she will tell. Increasing the number of turns. Yes, increasing the number of turns of the coil and increasing the magnitude of it. Simple. The two simple ones you missed. The top one you. It's okay. It's okay. It's all right. It happens. So I am teaching like in 10th classes. So slowly it happens. You learn today only, na? So what you have to say? Increasing the number of turns. Each winding is called a turn. And when the turn is more than one, then it is called coil. This is the difference between a loop and a coil. It has more turns. Okay. So 2 ways: increase the number of turns, increase the magnitude of. think both ways. आज बैठो और बैठो 8 मैसेज करें क्वेश्चन नंबर 5 सब आंसर क्यों देता है ये ये हो गया go back to so come to page number 208 question number 24 24 देखते हैं कौन कर रहा है page number 208 question number 24 draw in your notebook I will see ऐसे क्वेश्चन आएंगे एग्जाम में 24 न्यूट्रल पॉइंट का क्वेश्चन है होंगे कामयाब होंगे हो गया इसका हो गया कंप्लीट बताओ नहीं बनाओ मैं देख रहा हूँ नहीं तो कोई घर नहीं जाएगा जिसने नहीं बनाया वो घर नहीं जाएगा 3500 4000 4500 9 बजे तक हो गया डर गया डन श्योर Our magnetic field direction is also shown. You read the question. Read the question fully. See what is given, and then this is how mistake happen in the exam. They will twist. I told you, no? They will change the battery terminal. They will change the direction of current. So you need some practice. So this is Earth's magnetic field given in this direction. South to north, right? Earth's field is always south to north. So this is how the direction is given. And now the magnets. So Earth's field is always everywhere like that, right? And how is the magnet given to you? Like this. Then where should it be? Now for magnet, south enters here. So this is opposite. So obviously it should be somewhere here. away from the magnet. Right? Obviously, it should be somewhere here. Is it not the second case that we did today in the class?
Yeah.
How many of you got it right? Tell me honestly.
Second.
I have to see. Anyway, so it may take some practice, okay? Because now here I have taught you like taking Earth's direction south to north upward. Now they defined that it is this way, right? So accordingly you have to map it. Okay? So in direction question, sometimes it may be confusing. So with some practice, you'll be able. So wish you all the best for the success of the exam. Study well. Okay. Yeah, I'll be there for ICSE for all your doubts.
From the next step. From the next
I think
step. Sir, may I get?
वो उनको कुछ अलग टास्क किए हैं तो maybe after taking that it will.
On the body का है।
कुछ भी
हाँ, ऐसा ऐसा तो करके